Students, this is Ms.Maumita Datta from Thakur Vidya Mandir High School and Junior College. Welcome you all to online teaching 2020-2021. Today we are going to study about the fourth chapter, that is current, electricity and magnetism. Now already in the previous lesson we have already discussed about the potential difference, current, electricity and introduction of atom. Now today we are going to start with the electric cell. Now what exactly is an electric cell? An electric cell is a general device used to produce a uniform flow of charges in a circuit, and its main function is to maintain a constant potential difference between its two terminals, and these electric cells are used in many devices today. Now coming to the uses of electric cell. Electric cells are used in radio sets, wall clocks, wristwatches, torches, toys, mobile phones, cars, inverters, remote controls, ships, submarines and satellites. Now we are going to study about the dry cell. Now before I start explaining the working of the dry cell, let's have a look at the diagram of the dry cell, which consists of a positive terminal, negative terminal, carbon electrode, zinc cover, electrolyte, protective cover and manganese dioxide. Take a dry cell and remove its outer covering. There is a whitish metal layer inside, and this is the zinc metal layer, and this zinc metal layer is the negative terminal of the cell. Now break open this layer. There is another layer inside. An electrolyte is filled between these two layers. The electrolyte contains negatively charged and positively charged ions, and these negative and positively charged ions are the carriers of electricity. Now what is that electrolyte? The electrolyte is a wet pulp of zinc chloride and ammonium chloride. Now there is a graphite rod at the center of the cell. This is the positive terminal of the cell. A paste of manganese dioxide is filled outside the rod, and because of the chemical reactions of all these chemicals, electric charge is produced on two terminals and an electric current flows in the circuit. Now why these dry cells are convenient to use? Because they can be held in any direction with respect to the ground and can be used in mobile instruments such as radio sets, etc. Now we are going to study about the lead acid cell. Now from the diagram you can see that it is having two terminals, that is the positive terminal and the negative terminal. Lead dioxide and lead, these are referred to as the positive and negative terminals, and these two electrodes are being dipped in sulfuric acid, and the potential difference between these two electrodes is 2 volts. Now coming to this working of the lead acid cell, as already I told you that lead and lead dioxide are dipped in dilute sulfuric acid, and the chemical reaction between the substances in the cell produces the electric charges on the electrodes. Lead dioxide carries a positive charge and lead carries a negative charge. And the potential difference between the two electrodes is nearly 2V. And this lead acid cell can deliver a large current, and this cell can also be recharged after getting electrically discharged. Lead acid cells are used in cars, trucks, motorcycles, etc. Now we are going to discuss about nickel-cadmium cell. Nickel-cadmium cells generally are rechargeable, and these cells deliver around 1.2 V potential difference. And the gadgets which are portable, those gadgets are also using nickel-cadmium cells. Now already I have explained about the electric circuit, where an electric bulb, cell holder and plug key are connected by connecting wires, and a dry cell is fitted in the holder. When the plug key is closed, the current starts flowing, and when the plug key is open, the current stops flowing. On removal of the electric cell, the electric current flowing through the circuit stops and the bulb ceases to glow. Now coming to the concept of connecting cells, it has been observed that more than one electric cell is connected in an electrical circuit. Now why this is so? The purpose of doing this is to obtain more potential difference than that of a single cell. It is possible to obtain higher current. In this series connection, the positive terminal of one cell is connected to the negative terminal of the second cell, and the positive terminal of the second cell is connected to the negative terminal of the third one. Now we are going to discuss about the magnetic effect of the current through these two activities. In the first activity, you can see the inside tray of the matchbox, and in the second activity, you can see an iron nail. Now, in the first activity, the inside tray of the matchbox is taken. Place a magnetic needle inside the tray. Take a connecting wire and wind it around the tray. Take a bar magnet near the magnetic needle. The magnetic needle shows deflection as soon as the bar magnet is brought near it. The magnetic needle changes its direction when a current starts flowing in the circuit, and this means that the magnetic field is created when an electric current flows in the wire. In the second activity, we are taking a meter-long flexible copper wire and wind it around a long iron screw. Connect the two ends of the wire in a circuit. Keep some nails near the screw. As soon as the current starts flowing, the nails or the pins get stuck to the screw. When the electric current flows in the wire, magnetism is produced in the coil through the screw, and because of that, the screw attains magnetism. As soon as the current is stopped, this magnetism vanishes. Electromagnets are used to produce a strong magnetic field. Thank you.